Hey everyone, today we're diving into a mystery. A mystery that flows beneath our feet. It powers our world. It builds our cities. It has fueled wars and fortunes. We call it black gold. Oil. We've been told a simple story about it. For over a century, that it's ancient, that it's finite, that one day it will run out. We've been warned of a crisis. A day when the wells run dry and our modern world grinds to a halt. But what if that day never comes? What if oil isn't what we think it is? What if the story we've been told is wrong? Our story begins with a liquid, dark substance, a thick, that has seeped from the ground for millennia. Ancient civilizations knew of it. They called it pitch or bitumen. The Babylonians used it to mortar their great walls. The Egyptians used it in the process of mummification. It was a curiosity, a strange, sticky substance from the underworld. For most of human history, that's all it was, and water. Our world ran on the power of muscle. In the 19th century, of wind, then everything changed. The Industrial Revolution ignited a ravenous hunger for energy. We needed a new kind of fuel. Something more potent than wood or coal. Something that could light our nights and power our new machines. A few enterprising individuals began to wonder about that dark liquid. Could this be the fuel of the future? In 1859, a man named Edwin Drake traveled to a quiet town in Pennsylvania. He had a radical idea. Instead of collecting the oil that seeped to the surface, he would drill for it. He would punch a hole deep into the earth. People thought he was mad. They called his project Drake's Folly. One day, at a depth of 69 feet, his steam-powered drill clanked away for weeks. He hit obstacle after obstacle. His investors lost faith, but Drake persisted. And then the drill bit dropped into a crevice. The next day, the crew arrived to find dark liquid ... floating on top of the water in the borehole. It was oil. The first commercial oil well had been struck. The black gold rush had begun. It was a revolution. Overnight, fortunes were made and lost. Towns sprang up around the wells. The world had discovered a miracle fuel. Kerosene from oil replaced whale oil in lamps, saving the whales from extinction and bringing cheap, bright light to the masses. Gasoline, once a useless byproduct, found its purpose with the invention of the automobile. Oil became the lifeblood of the 20th century. It powered our cars, our planes, our factories. It became the key ingredient in plastics, fertilizers, and medicines. Our entire civilization was rebuilt on a foundation of oil, and as our thirst for it grew, a critical question emerged. Where does it all come from? And more importantly, ... how much is left? The answer that emerged became scientific dogma. It is the story we are all taught in school, the biogenic theory, or as we know it ... the fossil fuel theory. It's a story of deep time, of life and death on an epic scale. It begins hundreds of millions of years ago. The world was a different place then. Vast, shallow seas teemed with life. Microscopic organisms called plankton, trillions upon trillions of them. When these tiny creatures died, they sank to the bottom of the ocean. Their bodies mixed with mud and sand, forming a thick organic sludge. Over millions of years, layer upon layer of sediment piled on top. The pressure grew immense. The temperature rose. Slowly, relentlessly, the heat and pressure cooked this organic matter, transforming it into a waxy substance called kerogen. And with even more time and heat, the kerogen broke down further, becoming the liquid and gas we know today, oil and natural gas. This fossil fuel then migrated upwards through porous rock layers until it was trapped by a layer of impermeable rock, forming the underground reservoirs we drill into today. It's an elegant theory. It explains why oil is often found in sedimentary basins, where ancient seas once existed. It explains the chemical biomarkers found in crude oil, traces of ancient biological molecules. It became the bedrock of the petroleum industry, guiding geologists in their hunt for new reserves. But it also came with a terrifying implication. If oil is made from a finite amount of ancient life, and it takes millions of years to form, then it is not a renewable resource. We are using it up far faster than it can be replaced. This led to a powerful and enduring idea, the concept of peak oil, the theory that at some point, global oil production would reach a maximum level and then enter a terminal decline. For decades, we have been warned of this moment. Experts predicted it would happen in the 1970s, then the 80s, then the 90s. Again and again, the predictions were wrong. We kept finding more oil. We developed new technologies like fracking to extract oil from rocks we once thought were useless. The doomsday clock was always reset, but the core belief remained. One day, the party would be over. The wells would run dry. This story has shaped our geopolitics, our economy, our fears for the future. But what if it's not the only story? What if there is another theory, a radical, controversial idea that turns everything we know about oil ... on its head? This alternative story is known as the abiotic theory. It suggests that oil is not a fossil fuel at all. It is not biological in origin. It is primordial, a substance that was baked into the earth. From the very beginning, the theory proposes that hydrocarbons ... the molecules that make up oil and gas ... are a natural product of the deep earth. Imagine the Earth's mantle, a vast region of superheated rock under extreme pressure. The abiotic theory argues that under these conditions, carbon and hydrogen, fundamental elements of our planet, can spontaneously combine to form hydrocarbons. This process doesn't need ancient plankton. It doesn't need millions of years of cooking. It happens continuously, deep within the planet. These primordial hydrocarbons then migrate upwards, through deep faults and fissures in the Earth's crust. As they rise, they may pick up biological markers by flowing through layers of rock containing bacteria. This would explain the biological traces in crude oil. They are not the source of the oil. They are merely contaminants. The oil itself is abiotic, non-biological, and if this is true, it changes everything. It would mean that oil is not a finite resource. It would mean that oil reservoirs are not like static pools. They are more like springs, constantly being refilled from a source that is far deeper and more vast than we ever imagined. This idea is not new. It has its roots in Russian and Ukrainian science, dating back to the Cold War. While Western geology was built on the fossil fuel theory, Soviet scientists were exploring a different path. They observed that many of the world's largest oil and gas fields were located along deep fault lines, not just in classic sedimentary basins. This suggested a deeper, non-biological origin. They developed a comprehensive abiotic theory, and they used it to find oil. They drilled in places Western geologists would have ignored, in volcanic rock and crystalline basement rock, and they claimed to have great success, finding massive fields in Siberia and the Caspian Sea region. Their work, however, was largely ignored in the West. It was dismissed as Soviet propaganda, an outlier in the world of petroleum science. But the idea did not completely disappear. It was championed by a few outspoken Western scientists, most notably an astronomer named Thomas Gold. Thomas Gold was a brilliant and unconventional thinker. A professor at Cornell University, he was not a geologist. He was an outsider, and he looked at the problem with fresh eyes. Gold argued that the fossil fuel theory had major flaws. He pointed out that hydrocarbons are found throughout the solar system, on moons like Titan, in the atmospheres of giant planets. Where there is no evidence of ancient life, He argued that the deep earth must also be rich in these compounds. He proposed a deep, hot biosphere, a world of microbial life, living deep within the earth's crust, feeding on a constant upward flow of primordial hydrocarbons. This, he said, would explain the biological markers in oil. They are the remains of this deep biosphere, not ancient plankton. Gould's ideas were seen as heresy by the mainstream oil industry. He was ridiculed and dismissed. But he was determined to prove his theory. In the late 1980s, he convinced the Swedish government to drill a deep borehole into solid granite, a place where, according to the fossil fuel theory, there should be absolutely no oil. The project was called the Solgen Ring. They drilled for miles. The costs were enormous. The challenges were immense. They did find traces of hydrocarbons, about 80 barrels of a dark, oily sludge. Gould declared it a victory, proof of his theory, but the mainstream community was not convinced. They argued the oil was merely contamination from the drilling fluids. The project was deemed a failure, and the abiotic theory was once again pushed to the fringes. The fossil fuel story remained king, but strange anomalies kept popping up. Stories from the oil fields that didn't quite fit the narrative. Consider the work of Eugene Island, Block 330, an oil field in the Gulf of Mexico. In the 1970s, it was a major producer, but by the late 1980s, its production was in steep decline. Geologists estimated it was nearly empty. The field was on its last legs, but then something strange happened. The field started to come back to life. Production began to rise again. The pressure in the reservoir started to increase, and the chemical composition of the new oil ... was slightly different from the old oil. It seemed to be geologically younger. It was as if the reservoir was being refilled from a deep, unknown source. This phenomenon has been observed in other fields around the world, oil fields that were thought to be depleted, suddenly showing new life. The fossil fuel theory struggles to explain this. It suggests the models of the reservoirs are simply wrong, that there are pockets of oil we missed. But the abiotic theory offers a different, more direct explanation. The fields are being recharged from below. A slow, steady migration of hydrocarbons ... from the deep mantle. So which story is true? Is oil the buried remains of ancient life, a finite resource that we are rapidly depleting? Or is it a primordial substance, constantly seeping up from the Earth's core? A resource so vast it might as well be renewable. The truth is likely complex, and the debate is far from settled. The evidence for the biogenic theory is strong. The chemistry of oil, its location in sedimentary basins, it all points to an organic origin. The vast majority of geologists support this view. It is the foundation of a multi-trillion-dollar industry, an industry that has a vested interest in the story of scarcity. Think about it. If a resource is finite and dwindling, its value goes up. The story of peak oil justifies high prices. It drives investment and geopolitical strategy. Could the resistance to the abiotic theory be influenced by more than just science? On the other hand, the abiotic theory answers some nagging questions. The refilling of oil fields, the presence of hydrocarbons in strange geological locations, the sheer staggering amount of oil we have found, far more than many models predicted. But the theory lacks a smoking gun, a definitive proof that can't be explained away. Thomas Gould's experiment was inconclusive. The evidence from Soviet geology is hard to verify independently. The theory remains a compelling, but unproven ... alternative. Perhaps the truth lies somewhere in the middle. Maybe both processes are happening. Maybe most of our oil is from ancient fossils, but some of it is supplemented by a deeper abiotic source. The universe is rarely simple, so we are left with a profound uncertainty. At the heart of our modern world, we have built our civilization on this black liquid, and we don't even agree on its fundamental origin. One story tells us we are living at the end of an era, a brief, explosive century of cheap energy that will soon come to an end, forcing us to confront a future of scarcity and a desperate need for new energy sources. The other story tells us the opposite, that we are living on a planet that is literally soaked in hydrocarbons, that the age of oil is far from over, that the crisis is not one of supply, but of control and of environmental consequences. Maybe the real mystery isn't where oil comes from. Maybe the real mystery is why we cling so tightly to one story, why we are so resistant to challenging our assumptions, the quest to understand oil. Our future is a quest to understand our own world, our history, and the powerful stories we tell ourselves, stories that shape our reality. Whether those stories are about a dying planet or a planet of endless abundance, the truth is still down there, flowing in the darkness, as deep as the earth itself, waiting to be fully understood. Give us a like and comment your favorite theory or mystery you want us to explore next. Thanks for watching. A mystery. If you liked the story,